Hi guys, now we are going to see the topic about the dynamic memory allocation. What is dynamic memory allocation? See, the process of allocating the memory at the runtime is known as the dynamic memory allocation. See, we can allocate memory in two types. See, one is static memory allocation, another one is dynamic memory allocation. The static memory allocation already you know. Before executing the program, that is before the runtime, we will allocate the memory for the variable. Such kind of memory allocation is known as static memory allocation. See, for example, if you need to create a integer type variable at the start, if very first itself before running, we will create the variable integer a and we will allocate the memory. Next, while runtime, it's know how many memory you are allocating. If it is array, that array element, depending upon that, the memory space will be allocated. See, this kind of allocating memory for a variable is known as static memory. See, in dynamic memory, at the runtime, we can allocate the memory. After allocating the memory, by help of the pointers, we can store the values to that memory space. See, process of allocating the memory at the runtime is known as the dynamic memory. See, here they were the built-in functions. By help of that function, we can allocate the memories. See here, these are the four functions used to implement the dynamic memory allocation. Here, Malloc and calloc. These were used for allocating the memory, and we can store the values to the memory space. See, memory allocation is known as Malloc. Next, calloc, that is contiguous memory allocation. See here, the Malloc and calloc both were used for allocating memory. But main difference is here in Malloc, here when we are allocating the memory to that memory space, it will not initialize the value. Which one? Malloc. Suppose if you are allocating the memory, after allocating for each and every memory location, here it won't initialize the value. For Malloc, won't initialize value to memory. But here calloc, here it initializes after allocating the memory, block of memory, then to that block of memory it initialize value, that is 0. It initializes the value 0 to that memory location. See, for each and every time when we are creating the variable, at the starting time we will initialize the value. So that here for this and all we no need to initialize automatically. By help of this function, if you are creating the memory space, to that memory space after allocating the memory, then it will initialize the value 0. Suppose after allocating the memory, if you are telling to print this memory location values, here some garbage values will be display. Garbage values for Malloc. For calloc, after allocating the memory, suppose if you are telling to print the content inside this memory location, here it will print the value zeros. So this is the main difference. Here in Malloc, to this function, here only the single argument, we are passing the single argument to this function. For calloc, here there were two arguments. Here we will pass two arguments, argument 1 and argument 2. Here totally two arguments. See, these were the difference, but both the function Malloc and calloc, it is used for allocating the memory. See, now let us see the syntax about the Malloc. See, syntax, very first pointer variable here. Here pointer variable is equal to, next here cast type, that is pointer. Next here that function name Malloc. Next here single argument only, that is size. So that here what is the cast type? This one external typecasting, that is what kind of data we are going to, that is conversion, what kind of data we are going to store, that before that the memory allocation we are telling. If it is integer data type, here you should use integer, float means float, character means character. Here before that we should say what kind of data we are going to store to that memory location. Next here Malloc. Malloc, it is a function. Next size, total size, that allocation for that memory. Suppose if you want to store some 10 elements of integer, here I can use like this. Very first here that pointer variable which we have declared, that pointer variable here you should mention. Next after that pointer variable is equal to here typecasting, that is what kind of data, the type conversion, here integer. So here integer type of data. Next here that function name malloc. Next here total number of element into size of that data type. Here how many elements I need to store? 10 elements means here I should give it as 10 into here size of this size of function, it is used to, it returns the size of the data type, that is variable or data type. Here I am telling size of, here if I am giving integer, then what will be the size here? What is the default size of integer? Default size of integer is 4 byte. So 10 into 4 40. So this 40 byte were allocated by using this malloc here to this pointer variable. Totally 40 space were allocated, so that in this 40 byte, for example, if it start from address 1000 means it finish with address 1040. So here this base address were stored to PTR, so that here we can store totally how many elements? 10 elements. Each element, that is what data type? Integer data type. So in this way we can create. See, suppose if we want to create the character, we want to allocate memory for storing the character, we can allocate like character. So that here what is the default size of character is 1 byte. So 1 into 25 byte were allocated for this pointer. Let us assume this one PTR1, for this PTR1. Next here to that we can store up to how many letters? For this pointer 1 variable, it will allocate totally 25, that is space byte were allocated. Here inside we can store the letters, 25 letters, maximum 25 letters. So in same way for the floating point, here if we need to allocate the memory for space and if we need to store some floating data, floating point values, then here instead of here very first typecast, that is cast type, here you should give it as float. Next point variable, after that malloc. Next how many element you need to store into the next size of that float. If you give, depending upon that element what you have given, that will be multiplied with the size of that float, and after that the starting address, base address were stored to PTR, pointer variable. So that by help of that pointer variable, after fetching the address we can store the values. See, in this way the malloc were used for allocating. In calloc also, next let us see about the calloc. See, what main difference is, calloc it has the 2 arguments and it will initialize the value, that is the main thing. But moreover these both were same for allocating the memory. Syntax for calloc, very first here this also, first one this pointer is equal to, next here the function name calloc, after the 2 argument, first argument number of element, next here size, we are splitting into 2 argument this one. Example, if you are allocating integer type, then here what data type? Integer data type. Here for typecasting you should give external typecasting. Next here this pointer, after that this function name calloc. Next here n, how many element? 5 element. Next here size of, here if you are giving it as integer, totally 4 byte for this one integer default, 5 into 4 20 bytes were allocated for this PTR. Next in this PTR totally 20 bytes, that means totally 5 elements. Here each and every block it initializes with value 0. This is the main thing. Here if you are telling to print this one, it will print the value, initialized value 0 for this location. After allocating the memory for the pointers, then that corresponding for each and every block of memory it will initialize the value 0. See, next let us see about the reallocation. See, dynamically if we are creating the memory, after that suppose if we want to reallocate the memory space, then here by using this realloc function we can reallocate the memory. Say the syntax of the reallocation function is very first that pointer variable, after that typecasting, here next realloc, that function name, here the older pointer variable, that one you should give here where we had allocated that old pointer variable, next here size next, or we can give like this also, ptr is equal to, that is pointer variable is equal to, here directly without this typecast we can give like this also, reallocate the older pointer variable, next comma size, new size, for this also new size, how much we need. Say for example, if already if you are by using this malloc or calloc, if you are creating the memory space is pointer, if it is, let us assume this one integer type, here if you are allocating, there is a space for 5 element to store 5 elements. This is the previously created pointer variable, this ptr name, here totally 20 bytes. Suppose if I want to extend another 5 elements, if I want to append another 5 elements to the previous list, this is previous list, it has only 5 element. If I need to append another 5 element, that means I need totally 10 space. 10 space means it occupies up to how many byte? Totally 10 into 4, 40 byte. Each element it has 4 byte. So here previously I had allocated only 20 bytes only. So now I want to extend that memory space, means by using this realloc function, that is we can allocate. That is here we can give like this, that is pointer variable is equal to, here we can give like this also, what kind of data, integer type we are going to reallocate, realloc function name, that previous name is ptr, so here we should mention that ptr. What is the size of previous one? 5 element, that is totally 20 bytes only allocated. Now here I need 10 elements means 40 byte, so here we can give like this, 10 into size of int, so that here that is for to the previous pointer which we had allocated the memory, for that pointer here 10 into 440 bytes were allocated. We can give like this, or we can give like this also, or without this typecast we can give, because already we had defined this one. Here this one, otherwise ptr is equal to realloc, I am reallocating that previous pointer variable with 10 into size of integer. So previously I had given 5 element, here I had mentioned 10 into size of, so 10 elements can be stored, that this will be enlarged, here extra 5 elements can be stored. In same way we can increase the memory, otherwise we can decrease the memory also by using this realloc. Already if there is 5 space, if we need only 2 space, then we can reduce the space also. If you are giving here 2, then that 5 element memory space were decreased to 2 element space, that is 2 into size of integer data type, means 2 into 4 8, that is 8 bytes were allocated. Previously 5 into 4 20 bytes were allocated for that pointer. Now we have decreased it to 2. If you are giving here 2, then it will be decreased. So we can increase or decrease the memory for n pointers. See, in this way we can use this reallocation, realloc. Say for example, let us take the simple example here I am telling. Here let us assume this one. Previously this starting point is 1000. Here let us assume this block is newly reallocation block. This one previous block 1000 to 1020. Newly I have allocated another one 20 byte. 10 means 10 into totally at log here 1040. Up to this we can store the value. Suppose previously if we are creating the value 10,000 30, 50, 70 and 90. Totally if you are having 5 elements. If you want to append, you can do two things by using the reallocation. First one, append, or we can store it from first location also. See, append means previously what the value you have stored, from next to that we should give the element. So this pointer variable, it has the starting address, that is the base address. What is the base address? Here now currently 1000. Here we can store it like this. Here value at here ptr plus 1, that means value at ptr plus 1. What is the value here? Here ptr plus 0 means that is the 0th location. That is ptr value is 1000 plus 0, 1000. So to this 1000, what is the value? 10. Next, if you are giving ptr plus 1, then it will increment 44 byte value at here. Now what is the address? This one plus 1 means 1 into 4. ptr is 1000. 1004th location, the value is 30. So in this way, suppose if you are giving, this is the 0th element, first, second, third, up to 0 to 4 already they were element. We can give like this value at, otherwise directly we can give like this also. Pointer of 0, pointer of 1, in a similar way. Pointer of here, the 4th location is now currently 90 I have stored. Suppose if I want to append this value, we can directly give like this. ptr of here at the 5th location, if I am storing 200, then to this I am storing 200. So 200 were stored to the 1024th location. Here we can give like this also. At ptr of 6th location, if you are giving 300, then 300 will be stored. See, if you want to append, I am telling that lastly which one? Here this is in the position 4th position. So we can give like this. ptr of 5th location means that will be what you had given, that will be stored to the 5th location. From the 5th location we can continuously give the element, so that from 0 to 4th location what the element we have already given, that will be there. Here by we can append in this way. Suppose if you want to create newly, if you want to give the element to that reallocation location from the 0th location, here we can start from these and all append directly from ptr of 0 is equal to, if you are giving 300, then to this position already we had stored 10, that will be overwritten here, that will be become it as 300. ptr of 1 is equal to 200, then this with 30 will become 200. So that in this next here free is nothing but after allocating the memory, if you want to remove or deallocate that memory, we can use this free. For this syntax very simple. Here syntax for, now let us see about it is used to deallocate the memory. For already previously allocated memory, here we are going to deallocate. So here syntax is just you give free, after that pointer variable name, pointer name. If you are giving like this here, after, see for example, after finishing this one, when we are coming out, if we need to free up that memory space, then we can give like this free, and the ptr if you are giving means that memory block which we had allocated, that will be deallocated. So this will makes free. So very simple this syntax, just we are calling the function and passing the pointer which we had allocated the memory, that pointer name here you should mention. See, now let us see the simple program, how to implement the dynamic memory allocation by using this function. Now let us see by using the program. See, here we are using standard library.h, that is std.lib.h, because dynamic memory allocation function malloc, calloc, realloc, free, these and all inside this header file std.lib.h. So we should mention header file here. This program used to demonstrate Malloc function here. Now let us see the output here. Say I have declared the totally 3 variables. Pointer variable, that is what type, integer type, next I and n. Here this n is used for get the value, how many elements we need to store. Depending upon that, the memory can be allocated and the elements can be stored to the allocated memory. See here in the output display screen, it will ask enter how many number to store. Then this 5 is stored to where? By using this scanf function I am getting that 5 to n. So this 5 is stored to variable n. So next step here, PTR, I am allocating the memory for this pointer here, PTR, for this the memory were allocated. How much here? Integer typecasting, external typecasting, integer star memory allocation. Here by using this memory allocation I am allocating the memory n into size of integer. What is n value? I need 5 element to store. So here totally 5 elements I can store here. Into each element it has size of integer, that is each element it has 4 byte. So here it returns always byte, the size in byte. So here total byte is 20. So totally 20 bytes were allocated for this PTR. Next here, see if the memory were allocated, then we can store the values. Suppose if there is insufficient memory or if we are not able to allocate the memory for the pointer variable, then it automatically it allocated this one as null. If PTR is equal to null, then the memory were not allocated. So here I am checking, if it is null we can't store the value. So here if it is null, here I am telling memory not allocated. Next I should come out. So here we can give this exit. If you are giving exit 0, then come outside of this code. Otherwise if the memory were not null, this else part, this part will work. So here I is equal to 0, I is lesser than n. N how many? 5 values I had given. Next I plus plus incrementing. This and all same thing. You already know. By using this scanf function, I am for this pointer location. Here 5 element, each element pointer of 0, PTR of 1, PTR of 2 up to PTR of position. It gives for each and every position. Here I am storing the value. See, suppose if you are giving the value 10, 20, 40, 50 and 60, then to that particular location the address it will store. Suppose if you want to display, we can display like this also. Star operator, it is used for what purpose? Value at, here we can give like this also. Value at PTR plus, if you are giving I, here we can to that base address it will add the value. I value is 0. PTR, that is always it hold the value 1000 plus 0, 1000. After increment we can use any one. So that here in the output and finally I am telling to display this one. Here what I had given, that 10, 20, 40, 50, 60, these values will be displayed. In this way we can use Malloc for allocating the memory and we can store the values. Next let us see about the calloc. This one demonstrate calloc function. See, let us assume to allocate the memory by using calloc. Next we will store some floating point values, 10.5, 11.2, etc. up to some 5 elements let us store. 5 elements. After that let us sum this one, sum these elements, total elements which we had stored in this memory block. Finally sum that value and display the answer. See, this is the program. Here I am declaring the variable I and n. This is used for loop. This one is used for total number of elements, how much we need at the runtime we can get, and we can up to that we can allocate the memory and we can store the values to that memory. Next here float. Here I am going to allocate the memory for storing the float values. So here I am creating this pointer variable as float PTR. Next here sum. Let us initialize sum is equal to 0 here. See, here enter the total number of elements to store, or enter the total number of elements. Here we can, how many elements you need, you can give here scanf, after that percentage %d, here n value ampersand of n. Next here we should allocate the memory space for this pointer, so that here ptr is equal to very first that cache type. What type of data we are going to store? Float. Next here what function we are going to use? calloc. Next, what is the argument for calloc? Very first n, that is total number of elements. Here next size for each and every element, size of. Next here what type? Here float type, so that here we should mention it as float. See, if there is space, then the memory square will allocate that starting address were stored to pointer, starting base address were stored to this pointer. Suppose if there is no space, if the memory were not allocated, then here null were passed, that null value were passed to this ptr, so that here we can check here if ptr is equal to, if it is null, then printf. Here I am telling memory not allocated. Next I am coming out exit 0. Otherwise, if the memory were allocated for this ptr, then by using this for loop I am getting the input for I is equal to 0, I is lesser than n, I plus plus. Here by using this scanf function I am getting input to ptr of I is equal to sum plus here that pointer value ptr of ith value. What value you are giving at the time itself, that will be added to the sum. Next here I am closing this for loop. After summing this, again I am creating one for loop. I is equal to from 0th location upon that number of element. Here next I plus plus. Here I am telling to printf slash n percentage of f. Next here this pointer value at address. Next finally you are telling to, after printing this you are telling printf slash n sum is equal to percentage of f. Next here I am telling to print that sum value, sum. Next here I am closing the else part and I am closing the main part. See here main function open brace, this one, and that main brace function close brace were closed here. Next here if condition, this one, if this condition satisfy, then inside this if part this statement execute. Otherwise here else part, here this else part I had completed here. Next inside this else part, here this and all for loop. First for loop for getting the input for this memory block. Next for loop I am telling to print that element inside that memory block. After that here that sum value will be printed. See here enter the total number of elements. Last otherwise you can give like this, enter how many elements to store. So if you are giving it as 5, then this 5 is stored to the variable n. So here on this pointer variable float type of data I am going to store. So ptr it allocate the memory float type, how much? 5 into 4, 20 bytes were allocated. If it start from 1000 to 1020, here it allocate the memory for each and every element, 4 byte it will allocate. See, next here, if it allocate the memory, then it will allocate the memory and store the starting base address to PTR. Otherwise, here instead of storing the base address, here if the memory were not allocated, this PTR is equal to this null, this will be stored. So here if it is null, then I am telling to print memory not allocated, otherwise I am storing the values for the allocated memory. Here suppose if there were allocated memory were allocated, here for I is equal to 0 to n, that is 0 to 4th location, so totally 5 elements here I am getting for PTR of 5. Suppose if we are giving 1.1, 1.2, 2.3 etc. So that here after getting this floating value, here next here I am telling to print what the value I had get to this memory location, that will be printed. After that, here in this step, first I will get the value, next I am summing that value given by the keyboard, that will be added. That 5 elements value will be added what we had given, and finally that added value printed here. So in this way we can get and we can print the values. See, for Malloc and calloc we had already seen, the main difference is that it will initialize the value after allocating the block of memories. It will initialize that memory value. Next program, let us see how to see the initialized value. See, else part here I am writing, here in else see here main open brace, here close brace. Next here if condition, next else part, this else part start here and end here. See inside this else part, here for loop, open brace and close brace. See, now let us see output here. See, this program very simple, just I am creating the memory block. After that I am telling to print inside that memory block. See, inside that memory block, here as it is calloc, it will initialize the value. So here initialize the value to 0. See, in the output here enter how many elements to store. Suppose if you are giving the 5, then this 5 is stored to n. So now n will have the value 5. So that here by using this for loop I am telling to print the value, that is here it will print like this, printf, this message first it will print value at, next this open brace, after that %d, this I value printed here. What is the I value? Starting value 0, at here you should mention this, that is pointer name. Here pointer name is PTR. So here it will print like this, value at PTR, next open brace, here this %d, this specifies the ith value. What is the ith value? At the very first iteration ith value is 0. Next here is for this percentage of this position, that is value inside this location, pointer variable location. Very first I value is 0, so that base address, what is the value? 0.000 etc. So that here in similar way up to I will be incremented up to n time, that is up to 5, 0 to 4th time. So here at the value at pointer PTR of first position, second etc. up to PTR of 4th position, what the value initialized by this function, that value will be printed. Here it will initialize the value 0. So here that value, initialized value, we can see by using this program. See, next now let us see about the realloc. realloc function. To demonstrate realloc function. See here, now we are going to see about the realloc function. Here first we are going to store the rupees of the items. See, suppose if you are buying some items, groceries or something, if you are buying 5 items, then that 5 items price I should sum. Next, suppose if I need to add some more item price, then by using this realloc function I can add the some more item price and finally I can say the total rupees. So that here by using this realloc I am going to append the value to the previous item. I am going to append the value. See here how many items price. Here let us assume this item price as float. See, this one is pointer variable, item price. Another one variable for finding total price, TOT price. Initialize this one to 0. Item to use reallocate function. See here, totally here I had created the 5 variables. First one for loop used this I, next n number of element to store in the memory block. For that I had created the variable n. Next add item. See, after using the malloc or calloc, after allocating some memory, if you are storing some values, next to that if you want to append some more values, then by using this add item variable we can give the values and we can add the item. That is, we can reallocate the memory. For that, for reallocation, here I am using this add item. Next here it will ask how many item price to store. List of price we are going to store in this list. So that here, suppose here in n if you are giving the value as 3, so that here now let us create a simple list for storing the 3 price list. Next here item price is equal to, for this pointer I am creating the allocating the here n into size of float. So here n value is now currently 3 into 4, 12 bytes were allocated for where? For this pointer variable item price. So this item price, it hold totally 3 space. So that here if the memory were allocated, next it will goes to else part. Otherwise if the memory were not allocated, it will go to if part. Here I am checking. So that here I am checking here, if item price is equal to null, then memory space not allocated, this message will be displayed and it will come outside of the program. Here if it is allocated, next it will go to the else part. See, in the else part I am creating the for loop for getting the input for the multiple values. Here n value is 3, so I need to give the 3 price values for the array. So here I is equal to 0, I is lesser than 3, that is from 0th position to 0, 1 and 2. For this each and every it has address. If it is start from 1000 means 1000, 1004, 1008, that base address here is 1000. So that here for the 3 values, suppose if you are giving the price here 10.5, next 20.5, next 20. So that for each and every time after the first element 10.5, so price 10.5, 10 rupees or 50 paise were stored to where? To the 0th location. At that time, next to the statement I am telling price, total price is equal to total price plus item price of ith value. Say total price I can initialize to 0. So here at this step, at the first iteration, 0 plus this value at 0th position. What is I value is 0. What is 0th position? 10.5. So 0 plus 10.5 is 10.5. Next I value will be incremented. Now I value is 1. Again it will get the value for the, it will get the price for the first location. Suppose here if you are giving 20.5, next previous 10.5, now currently total price is 10.5. 10.5 plus 20.5 is here 31. Now currently total price it holds 31. Price is 31. Next to that I am 31 plus 20. 20 means here 20.0 if you are giving, 51 is the answer. So finally here total item, totally how many item here, this will print. In the end we had given it as 3. So here in the output total item, this will display total item is equal to 3. Next total price for all item. So after summing the all item price here, that is net price here, it will display. What is the net price? 51. After that do it here, the message I am asking, do you want to add some more item price? Here this is character variable, here I have declared you should give single letter, you should give the single letter input. See here the main thing is here, by using scanf we can get the single letter for this ch, variable ch. Otherwise by using this, these are the function get ch, get chi. By using this function we can get the single letters to the variable ch, or we can by help of the get ch also we can get the single letter. So we can get the single letter to ch. See, suppose if you are using this scanf function and if you are getting the input to the ch, means here say first scanf percentage c, next ampersand of ch. See here for this percentage c, here one space you should leave, scanf, after that one space percentage c, next continuously comma ampersand of ch. Here one space you should leave, this is one space in between percentage and this open apostrophe. Here within here one space you should leave, then only we can get the single letter as a input for the variable ch. This is one space, after one space percentage c, next ampersand of lowercase letter y. If you give lowercase letter y, then it will continue, otherwise it will, if you give some other letters, it will come outside. So here if you are giving y, lowercase letter y, then here again this process will continue. Enter the number of item price to append. For appending I am telling here, suppose again if you are purchasing some 2 items, we need to append that 2 item price to, so that here suppose if you are giving 2, then the 2 will be added to where add item. This add item, it is used for adding the appending the item. So already we have stored 3 items, now we are going to append the 2 more items. Here item price is equal to, here I am reallocating the old, that is previous pointer variable plus here that new memory allocation. Here I am giving the memory allocation, that is n plus add item, n already 3 plus 2. So 5 into size of float is 4, that is 20 bytes were allocated. So 1000 to 1020 the memory address were allocated for this item price pointer. So here next, after allocating the memory, here for I is equal to 0, I is lesser than add item. What is the add item value? Add item value is 2. So from 0 to lesser than 2, that 2 items we are going to add. Suppose if you are giving the price for first item 10.5 and the second item 20.5, this also for each and every time that previous total will be added to the current total. Previous total price is how much? Now currently 51 is there. Suppose if you are giving 10.5, so that 51 plus 10.5 is 61.5 is the value. Again for the, when I is equal to 1, that second item will be appended. So while second item appending, suppose if you are giving the 20.5 for the second item, so that previously 61.5, now 20.5, totally 82 is the answer. So here the total price is 82. Now I am telling n is equal to n plus add item. So n plus 2 is 3 plus add item is 2, that is 5. So now currently n value will hold the value 5. So here from 0th to 5th location, I am telling to print from starting address, that is print every price list. After that finally here I am telling total price for that item. What is the total price? Finally 82. That 82 will be printed. See here, next here I am using this free. This is the last memory function, that is free. Here I am using free. That is I am going to deallocate the allocated memory. See, by using Malloc and realloc we have allocated the memory. So that at finally after completing the process, before coming out we should free up that space, deallocate that space. For that here this free is used. So in this way we can allocate and deallocate the memory space. So by using this function at the runtime we can allocate memory, reallocate or deallocate, anything we can do by using these functions.